Hey everybody, I hope you're all doing really good. So today I'm working on an iPhone, no wait, this is an iPad. I'm working on an iPad 8 that was in here because it will not charge the battery. Normally whenever something shows up as a box or a bag full of parts, I get a little bit discouraged, but in this case, I think we're doing pretty good. So here's what this thing looks like as it comes out of the box. Now, this was actually just laying in here like this, and that is pretty much so far the only thing that really makes me nervous, because whenever these things are not secured and they're left to flingle around inside the box, I have had a couple of times the dock flex actually gets torn free from the board. This one actually looks pretty good, and we got a SIM card kind of roaming around. I want to make sure and keep that safe and don't lose that. I'm really not sure if this customer is looking to have everything put back together or if they are just wanting the iPad to be, wanting the motherboard repaired. It looks like they have a brand spanking new digitizer ready to go. Here we have what is hopefully going to be the LCD that goes with this unit. I'm just going to go ahead and set those things aside. All right, and then we got the main housing. I'm not actually going to worry about much else that is in that box at the moment. We are just going to go after this. So when iPads show up here as board only or fully sealed or whatever, and they're having charging issues, one of the first things I do is use a TriStar tester, because this a lot of times will help you narrow this down really quick. Now these aren't completely fail-safe. They're not 100% accurate, but they are accurate enough to give you a more of an educated guess as to what's wrong. So I'm gonna go ahead and push the button. Okay, this one immediately jumps to TriStar/Hydra fail. That actually gives us pretty significant odds that this one just has a TriStar failure. The next thing I'm going to do to this unit is go ahead and connect a charger. And the charger is drawing 0 amps. We're at 5 volts, 0.0 amps. And I'm just going to check it and see if we get any voltage at the battery terminals. So that's going to be, the polarity here doesn't matter. Okay, so at the battery terminals, you can see that we are getting 2 millivolts, and that is with a known, 4.7 or 5 volts going here on the USB port. All of this gives us very significant odds of this just being a TriStar failure. I'm always dogging people that cut the metal shields on these and cut things to do the repair. So let me show you what we're going to do to get this fixed, shall we? Now, because of the amount of heat that I'm going to have to use to do this repair, I'm going to go ahead and peel the sticker off of here. If I don't, the sticker is going to get melted and gnarly, and it will just look all kinds of bad. So let's just carefully peel this off here, because I do plan on putting it back on. I'm going to be trying very hard not to tear it. Ah, dang it! So then, the chip that I'm going after, it's actually wedged up under this shield right here. It's just about half covered. Now, you can sort of like fish this thing out from under there and do this without causing any carnage, but this one here is easy enough to make some room. Let me show you what I do to get this one changed out. I'm going to add a little flux to this spot here and this spot here. And then I'm going to take just a smidgen of 138 degree low melt. And just to remind you all how easily this stuff melts, I don't know if you can see this. I'm going to touch the end of this with the iron and just watch the melty pattern travel down this blob. I don't know if my camera will have the resolution to capture that, but it melts so easy. It'll actually stay molten for a very long time. I'm just going to add a little bit of this right here to the shield to make my life a little bit easier. I'm going to add a little bit right here. Maybe a little more than that. And then a little bit right here. So now that I have a smidgen of low melt in there, I'm going to take my hot air and flood that in there a little bit better. Just because I want that to mix really well with what's on the board. Should probably do this in the other order. I'm getting ready to make a couple of cuts here. All right, so there I've got that all flooded with some hot air. Now I'm going to take my razor blade, number 11 X-Acto blade, and I'm going to be trying really hard not to drive this through my finger today. Okay, so the first cut I'm going to make, it's going to be right here. And then the next cut I'm going to make, it's going to be right here. And I've chose those two locations because it's directly on the outside of both of those solder joints. And now that I've made our little bit of just a little bit of an incision there, I'm going to try to pop this up some. And that should help me to get this blade to go through it. That. I'm going to do the same thing here. Okay. And let's see if we can go down with this now. Not too far, because if you go too far, it's going to go ka-chunk. And then life just got miserable. Whoops, almost went too far. All right, so that's probably pretty good. I'm going to stop right there before I make a total fool out of myself and drive that blade into the board. Okay, looking pretty good there so far. All right, let's get her clamped down a little bit, shall we? Now I've got this thing clamped into a holder. I've got my hot air set on 340 degrees C with an airflow of 40. And I'm going to use my screwdriver now. Oh look, I broke one of those components off the boards. Is this ever going to go as planned during a video, ever? I'll have to fix that now, won't we? Alright, so I'm just going to go ahead and warm up my low melt here. Actually, let's add a little flux so that it will flow. And as that low melt warms up, it's going to allow this shield to come off of the board real easy right here. There we go. And then the places that I've cut, they'll come loose really easy. Come on, baby. I mean, the places where I've flooded it with low melt will come loose really easy. All right, so I'm having a little bit of trouble with that. Let's do a little bit more cutting. There. Get more cutting there. Should actually just use some toenail snippers. All right, let's see if we can get this to start wiggling. There we go. It's just marvelous. All right, now we knocked a big old chunk out of there. I'm going to take right away some wick and wick this low melt out of the way because that stuff is disgusting. Trust me, it's not as ugly as it looks. Once this repair is done, you're not even going to be able to tell that I did this. All right, now, before I lose track of that capacitor that I so carelessly knocked off the board, let me just fix that first. And not only did I knock that off the board, but I've also tore it up. Like, I can't put that capacitor back on the board. If you look really closely, a chunk of that capacitor is still hooked to the board. So I'm actually going to go ahead and just replace that whole entire capacitor. So I'll get some leaded solder in here on one side. Throw that cap away. And yeah, look here really close. There's a chunk of that capacitor, or maybe even two chunks of it left on the pad. I broke that all the way off the pad carelessly. So let's get rid of the little chunks of cap that are left over there and leave us a couple of nice shiny domes. And now let me grab an iPad 8 board. Dang it. Bring forth the sacrificial iPad 8. This started out as an iCloud locked iPad 8 and it moved on to me needing an LCD and some parts here and there, and we'll just pretend like that didn't fall out. Yeah, I'm really not exactly sure what line this is on. It's probably just main caps, but I'm not completely sure. So let me just make a little room here to get in there and snag one of them up out of there. Slide me a shield down between the board. And let me just snag us a cap out of here. Now, with the board in the housing, it actually takes significantly more heat. Anybody want to place any bets as to whether or not the cap comes off the board before the battery catches on fire? Any moment. Now we have us a brand spanking new capacitor. It's gigantic. Back down to 340. And we'll just sit that right back on the board, right where the other one used to be before I mutilated it. Surface tension is going to put this in place for us any moment. Backing away, letting the heat spread. Here we go. And there we have a nicely soldered cap. Now, before this board cools off, I do need to do some actual work on this. So now that I'm done tearing up this customer's board, I think I'll go ahead and fix it. So I'm just continuing on with 340 degrees C and an airflow of 40. And we're going to lift this component off the board as soon as it's melted. There we are. Now, some people wick these. I don't, because I've been through so many of these. Now we're just going to smooth out the pads here using some leaded solder on my iron. Just like that. And now I will take a brand spanking new TriStar IC, which I should have already gotten out, but I dropped the ball and I didn't, so now I have to dig around and find it. Aha! TriStar ICs. There go giant IC. Now it is very important to get this orientated the way that it should be. And if I remember correctly, it was turned just like that. So that's going to get placed on the board down in there just about like that. Now, I do want to add a little bit of flux, fresh flux to this for two reasons: to keep it from blowing away, and also, shoot, I just blew it away. If I were a TriStar IC that just got blown into the abyss, where would I be? Oh yeah, right over here next to this big old coil and two diodes. Anyways, moving right along with this repair. So this is going to sit down in here just like that, only this time I'm going to try extra specially hard to not blow it away. So I'm going to hold this in place with my tweezers, making sure to line it up right on top of all of the balls, and begin warming this up. Okay, any moment it's going to settle down into place, or it's going to blow away. Which of the two? Yes. Give it a little nudge. One more little nudge. All right. Now we have a beautifully soldered 1610A3B IC, I think it is, and I'm going to go ahead and clean it up with some alcohol. Oh yeah, and let us not forget our brand spanking new capacitor. You know, since I did add a new capacitor to this, I could probably double the price. You know, I added a new capacitor. Okay, so that has this thing cleaned up just as far as I'm going to go with it. Brand spanking new cap, brand spanking new TriStar IC. Now that new cap is probably some standard value, but to make things quick and painless, I just snagged that off of a donor board. That way I don't have to spend any time trying to figure it out. Now I could have fished the little chip out from under the metal bracket here like I do on, like, say, an iPhone 7 or an iPhone 6S. But on this model, we've got this snap over metal shield that goes right over the top. And if we put that on there and we just snap it right back down into place, it pops back down on there neatly, click, click, clickety, click, click, and it covers that up. It's just like nothing ever happened. So it doesn't actually leave a big old gnarly cut spot on the board. And if it ever needs that chip replaced again in the future, you pop that bracket off there and it is wide open. So now we have replaced the TriStar IC. We have a brand spanking new capacitor. We're ready to find out if this thing works. Okay, so the TriStar testaroo first. Yeah, and hopefully this one doesn't also need a dock flex. It should be okay from what I'm seeing. There we go. Dun 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 dun. It already went farther than it did before. IC test. Additional test. Come on, baby. All right, TriStar test okay. Check VCC main. So the message that says VCC main, I actually think that comes up sometimes on iPads at random, or maybe because we don't have the battery connected. So let's see what we get on the voltmeter. So just the same as before, we're putting in 5 volts at the USB connector. Now the amp meter, instead of drawing 0, it's actually pulling a little bit of current. So we're now drawing almost 100 milliamps of current, which means when we check the battery connector here, we should actually get some goodness. We should be pumping up some voltage. And there you go. We're sitting at 1.6, 2 volts, 3.9, 4 volts, 4 volts, 4 volts, 3.9. It's sort of just all over the place. And I would sort of, there we go, 2.8, 2.2, 1.8, 4 volts, 4 volts, 4 volts. It's sort of all over the place like I would expect for it to be. That is a very good sign that the battery charging circuit on this is now working properly. It's trying to charge a battery, only there's not actually a battery here. And I do have to say, the technician that took this all apart, he did a very good job at not marking anything up and not tearing anything, didn't damage the battery connector. Very often when these things show up here and they've already been taken apart, it is just absolute carnage. And sometimes the customer will take it apart for you to try to save you some time and get a better price. And they just, man, oh boy, do they make it harder. So this thing is ready for a test. I'm going to get it slipped back into the housing that it came out of, assuming that housing is okay. And let's see if it'll charge a battery. I'm going to check and make sure that the dock flex doesn't disconnect. Make sure it doesn't need a charge port too. And then we'll check and see if it powers on. It's going to be fine, right? So here I have the customer's LCD installed in here. And I have got the battery connected and screwed down. I do have test screens for these, but I like to make sure that this is good. So if there's any problems, I can let them know ahead of time. And now I'm going to go ahead and connect a charger and see what happens. So right away, we are drawing 150 milliamps of charging current. One amp of charging current, and we have a battery charging icon. And this thing is most likely going to be good to go. It does look like this screen still has a protective film over it, so that's really good. That means we can ignore the fingerprints that I see all over it, which I know they're not mine. And all right, we are still drawing 1 amp of charging current. It kind of dipped off just a little bit. I'm going to wiggle the charger around. Yeah, see, and as I wiggle the charger around, it's staying steady. We're staying at 1 amp of charging current no matter where I wiggle it, which means the charge port is going to be completely fine, and I'm going to leave that exactly like it is. This is going to be just a straight TriStar repair and nothing else. All right, I'm going to let this thing charge for a little bit and clean up some tools, and I'll be back in a moment. Oh, we have Apple logo. and this thing is booting. I'm gonna let it start up here and make sure we do pick up a couple of percentages on the battery, and also make sure the battery charging stays as it should. Now here's an interesting thing here. I don't actually have a digitizer hooked up at the moment, and this is what we classify as normal behavior. I'm not touching anything, but it's sort of going completely nuts. And that's actually what this thing is supposed to be doing without a digitizer hooked up. This thing is going to be good to go. So I'm gonna get in touch with the customer and see if they want me to do anything else with the housing. It's actually quite a bit more work to reassemble this thing, because to put this back together in a way that I would be comfortable, this housing actually has to be cleaned, completely spotless down to the bare aluminum. We can't have all this goop and goo here. This has to be cleaned absolutely, totally spotless. So that's going to be it for this one, everybody. Let me know what you think in the comments below. Also, if you like my videos, please give me a big thumbs up. That really helps me to keep going, and I will see you in the next one. Have a good day, everybody. Thanks for watching. So I wound up finding that this thing had a torn Wi-Fi antenna at the bottom right and at the bottom left, so both bottom antennas were torn. I also found that the bottom left speaker flex cable was torn free from the speaker. And then up at the top, there's a big old chunk missing out of one of the cellular antennas. You can see sort of, yeah, you can see that right there. Look at that big old chunk missing right there where the blade went through it. Like, that's not any good at all, is it? So cleaning the frame actually wound up being the easy part on this. Cleaning up all the rest of that nonsense was a little bit more time consuming. For cleaning the frame, I just use a microfiber cloth with alcohol after I scrape over it with a blade, of course. So there you go. We've got two brand spanking new top antennas. I've replaced the missing metal bracket with all 3 screws. The frame is cleaned up and all ready to go. And for the bottom antennas, I actually harvested that whole entire unit directly out of another iPad, so I was able to get the sticky tape and everything just as it should be. Let's not forget the crack in the frame that I had to beat out with a screwdriver. Just look at this pile of stuff that I wound up replacing. There's one of the lower antennas that just seems to be missing a chunk where I believe a blade went across it. And then on the other side, same exact thing. That actually wasn't tore all the way off whenever I first started. I may have finished that one off. And then these, I think somewhere in the beginning of this video, I mentioned something about the customer taking it apart sometimes to try to make things easier for you. Yeah, that was a big mistake. So there you go. We've got it all put back together and looking good as new. And how about that? I didn't even get any dust under the digitizer that I can see, and we are up to 30% battery.